Hi everyone. Today we're going to look at comparing data displays. And the first problem we're going to look at is this. Leonard measured the mass of each pumpkin in his patch for the nearest tenth of a kilogram. He then created both a histogram and a box plot to display the same data. Both diagrams are shown below. Which display can be used to find the maximum mass? Okay, so that's the first question. Which display can be used to find the maximum mass? And the second one is, which display can be used to find that there were 25 pumpkins in Leonard's patch? So let's take a look. Okay, here is the histogram for Leonard's pumpkin patch. And here is the box plot. Okay, so as you can see, to find the first question, right, to answer the first question for maximum mass, the box plot clearly shows that our maximum value is at 14. However, for the histogram, it gives us this bin or this bucket, and it says that there are two pumpkins that are in the range of 12.0 to 14.9 kilograms, right? So, but we don't know. We don't know exactly whether it's 12 or it's 14.9. It could be somewhere in there. So this bin tells us that these two pumpkins are somewhere between 12 and 14.9. So it doesn't really give us the maximum value for the mass of the pumpkin, right? Here it's very clear that the maximum mass of a pumpkin is going to be 14. So for the first question, it looks pretty obvious that the box plot is the winner. For the second one, which display can be used to find that there are 25 pumpkins in Leonard's patch? Well, if you look at the box plot, you really can't tell how many pumpkins we're talking about here, right? There's not enough information here to tell us how many exact pumpkins we have. All we know is we have the minimum, the maximum, the median, the quartiles, right? And the fourths. So we're not really sure how many pumpkins. However, here, this is obvious because we can count how many pumpkins there are, right? There's 4 here, there's 5 here, there's 8 here, etc., etc. So all you have to do is add up the buckets or the bins. So in this one, the histogram seems to be the winner. So when you need to find out exactly how many pumpkins there are, histogram's the way to go, right? Or if you need to know what maximum minimum values are, then the box plot is. Okay, and that is correct. All right, let's move on to another one. Regina is a realtor and studies house prices. She recorded the area of each house on Prince Street. She then created two histograms to display the data. Histogram A shows the data using a bin width of 50, and histogram B shows the same data using a bin width of 100. Which histogram can be used to find how many houses had areas less than 150 square meters? Okay, so already you can tell that if it's 150 square meters, chances are that the bin widths that are 50 are going to be more accurate instead of 100, correct? Because the 100 you only have from 0 to 100, 100 to 200, etc. 150, well, 150 is a multiple of 50, right? So already we can tell that maybe A is going to be the better histogram. But let's take a look, all right? So here is A, and we can clearly see that these two bins or buckets are the ones that we're talking about, correct? So we have 4 here, and then we have 7 here. So that makes up a total of 11, right? So 11 homes have an area less than 150 square meters. Here, 150 is right in here, like we said, correct? So it's right in the middle of a bucket. So we cannot tell exactly how many houses in this bucket are less than 150. So therefore, it is very obvious that histogram A is going to be the superior choice to answer this question of how many houses have an area less than 150 square meters. Okay? Let's take a look at the third one. Leo owns a hostel and counted the number of guests staying in each room. He then created both a histogram and a dot plot to display the same data. Both diagrams are shown below. Which display can be used to find that there were 2 rooms without guests? Okay, so again here we have a histogram and a dot plot, and it says which display can be used to find that there were 2 rooms without guests. Okay, so here in each one we have guests in the hostel rooms, and then we here have number of guests and number of hostel rooms. Okay, and here's the dot plot for that. So which one would be superior? Well, it says here which display can be used to find that there were 2 rooms without guests. Okay, so let's take a look here. So here, this histogram tells us that here are the number of hostel rooms, and here are the number of guests. So for the number of guests between 0 and 3, we have 3 hostel rooms, right? So therefore, we don't have any rooms that are not used by the guests. Here, from 4 to 7, okay, we have 5 rooms. Okay, and then here we have 8 to 11 guests with 8 rooms. So, and then 12 to 15 with 6, 16 to 19 with 3, and 20 to 23 with 1 room. All right, let's take a look at the second one. All right, so each dot here represents a room, right? So here with 0 guests, we had 2 rooms. So automatically we can see that there are 2 rooms here with no guests. So this dot plot clearly shows us that these 2 rooms had 0 guests. So in answer to this question, which display can be used to find that there were 2 rooms without guests, the dot plot looks like it's clearly the favorite, right? Which display makes it easier to see clusters and gaps in the data? Okay, so take a look, clusters and gaps. So here, for the same data, we can see that there are gaps here, right? There are gaps in here, and there are also clusters of data. So again, it looks like the dot plot is clearly our choice. So that is correct. It looks like the dot plot wins out on both. And finally here, Sal counted the number of songs on each album in his collection. He then created both a dot plot and a box plot to display the same data. Both diagrams are below. Which display makes it clear that none of the albums had 15 songs? Okay, none of the albums had 15 songs. Well, here on the dot plot, we can see clearly that there's a gap. There are no albums with 15 songs. So again, the dot plot makes it very clear. Here, we don't know because 15 here is part of this whisker. So again, the dot plot is making it very clear. No albums with 15 songs. Which display makes it easier to find that the interquartile range is 4? As soon as you see the word interquartile, you're thinking box plot. Why? That is the advantage of a box plot. You could see quarters of data, right? Separated by whiskers and boxes. So again, here, this is the box plot. To find the interquartile range is 4 songs. By the way, interquartile range is the range from the first quartile to the third quartile. It's the range from the left side of the box to the right side of the box. That's called the interquartile range. So in this particular case, the interquartile range is from 9 to 13, or 4. Right? So the interquartile range here is 4. And there you have it. Okay, guys? Take care.